I just realized I was muted, so I do apologize for that. One moment. Okay, so I didn't realize I was muted this whole time, but I will try and summarize what I've been talking about so far. We have a display driver that we have implemented for this project, and I want to port it over to a standalone package, right? And the what I was saying about the MicroPython Framebuffer class is that you need enough space to hold every pixel, right, of the width and height and format, right? So assuming you have an RGB 888, right, each pixel is going to be 24 bytes, right? And so if it was so let's say 214 times 320 times 3, right? Because we got 3 bytes per pixel, right? And so we wouldn't even be able to fit that on the entire 256K of RAM, because remember, MicroPython also has to load and live in memory, right? And execute its store some data in memory, and right. So what our plan is, or what we did in this project, or I did in this project, was to create a frame buffer implementation that uses a fixed size, right? And one of the reasons why I went that route is because the frame buffer class is readily available in all ports of MicroPython, or most ports of MicroPython, and it is written in C, which is usually faster, or faster than MicroPython, right? So right now we can see this example is taking us about 34 milliseconds to render, and we will see how long. Let's just go ahead and compare how long that takes with the frame buffer class, right? So let me just uncomment this out. We can do that, right? So we're doing the same thing. You'll be able to tell from the once the demo runs, but now we are creating our frame buffer for the display. We are creating, or we create a buffer for the display, sorry, and then we create a frame buffer, and then finally we fill our frame buffer with the color, and then we render it out with our slight change to our display driver, right? So our display driver is based on the package, on this package here. I'll put a link to that in the description, so you can check it out, right? It supports both MicroPython and CircuitPython, but I stripped out the CircuitPython part so I could focus on working on the MicroPython part, right? And so, and also I should mention that the fill rect that we use in the first example comes from this library, and it is written in Python, and so that is why it is relatively slow, right? So let's write the same example, but let's run this file, which is what did I just get rid of? So let's just go ahead and try that. So it's ILI micropy. Jesus Christ, right? They give such a long name. And okay, let's see. Right. Okay. So we can see the actual rendering or filling of the frame buffer is relatively cheap, right? It's relatively inexpensive to fill out a quarter of the display. It takes about no time at all, right? And let's see, I hope I'm measuring this correctly, right? The fill rect, and then we render, and then let's see. For some reason, it seems a lot slower. Blah, blah, blah. Okay. Right. At the very least, it stays constant, right? I wonder why. Did I do something different? Am I timing it differently? Right. I think so. Okay. All right, let's try with the full example. Maybe that'll make a lot more sense. I should have just kept it how it was. And let's try this one more time. No, not this example. I'm gonna try the demo example. Sorry. Okay, so renting out the full example there takes quite a bit of time. Now let's try that here as well. So we've got this, and then I think we also have the time in the center, right? But I don't think we've got that here. So let's just go ahead and yank this, and we will text of it. What do we call this? Fbuff. Text. And so what do we do? It's just a simple string. Okay, so let's go ahead and just fix this up. We got our color, we fill in our buffer, and then here we need our text. Let's set that up here. dt equals 0. Let's just bring that back in frame. Okay, so our dt is 0, and right. Okay, I get why I did that. Yeah, maybe I should have just copied it, and it would have saved so much time. Okie dokie. So what is the Framebuffer class need for us to render text? We need the X, Y, and the string and the color, right? So we've got our string, we've got our X, our Y, and then get rid of this. And let's just go ahead and let's do that. Okie dokie, and let's try it again one more time, but with this. And we can see the time has barely changed, right? So the C++ C implementation is way faster, right? And for most things, and we can make it faster for everything. I think maybe it's just the alignment of our memory, the way in which we're writing the data. Okay, so I guess we should just jump in and start implementing. I don't know if this is going to be distracting to people, right? Looks like a bit. Okay, so sorry about that. So we just want to go ahead and start porting that over, right? So yeah, let's just go ahead and define our class. Okay, and I guess maybe I should give a brief explanation of how that works, right? So we can take a look here. So how this works is we're gonna have, let's call it screen. Class screen, and should just say, and what do we want to do? We want our display width, display height, next we've got our buffer. So just go ahead and just set this up properly. And do right. And what else do we need? Okay, I guess we can just start with these. Oh, and yeah, we'll also need access to the driver, right? So driver. Let's just leave that for now. And I will do I want to re-implement this or just refactor? I think I'll refactor, so I don't have to. Okay, I'll refactor and I'll explain as I go along. Right? I think that'll be a good idea. So in our application, right, sometimes you have different assets that we store in memory, or that we store on the flash, and we want to render, right? And so because the whole point of this is to reduce our memory allocation, right? We also need some kind of buffer to hold whatever we are going to be drawing into that buffer, well, before we can draw. So that's what this asset buffer is for. Oh yeah, we also need the format of the screen. And so, yeah. Okay, and then I think I set buffer size, and I'll explain the render queue length, and then also the FPS as we go along, right? So yes, FPS is kind of self-explanatory. Yeah, that's not what I need to do. Right. Cool. So, what do we want to do next, right? So we just want to go ahead and then just keep a reference to these items. I want to keep the names the same so it works the same while I just like copy and paste it, right? I don't want to have to refactor every single thing. But I do want to make it I do want to make a more convenient API that is accessible. So display width. If you have any ideas for what could be better, I'm gonna call this driver instead. That'll make more sense. Driver, since we added driver, this can be driver. Right. We got our max scaling and our FPS, right? And then also, I think we need to keep a reference to our buffer and a buffer and our buffer size, and also our asset buffer. So let's go back here. Our buffer length, and our asset buffer. Should probably just get rid of here. And all right. No, should be an int. This is an int, but I do want it to be an enum. And we've got driver asset buff. Okay, buffer blah 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 blah. With height format, right? Okie dokie. So let us go ahead and create a little test script that just creates our screen object, right? So we can do we want to initialize our first we need to initialize our driver, and I'm just gonna yank. Oh geez, I don't want to go through all of that one more time. Okay, I just gotta copy the pins. Right, what else do we need? I hate this copy and paste. Yes. Okay, so we need to create some pins, and then our SPI. Where do we create our SPI? Okay, we create our SPI here. Let's just copy this. So if we come here, we actually in screen. So first of all, let's get rid of this. And let's do this. So we create our SPI. We can get rid of that actually, or just refactor this here. And just make okay. Okay. Okay, so we're missing a few imports that we need to go ahead and fix. Let's we need to import machine, right? And we also need to import this, and this should do the trick. And next, so I think we call this driver. And I guess we can call this screen. Equal to our screen class. It also needs our display width. I feel like we should pass the driver first. Kind of seems off. All right, let's do display width, display height, buffer. We will create that. Let's just call that for now. And we will create our format, which is buff. RGB 565. And so I got blah 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 format, and is that the format? Width, height, buffer, driver, right? Yeah, the driver's in an awkward position. Let's say driver, and so let's come here and let's get this over here. So get a driver, width, height, our buffer, our format. What else? Asset buff. Sure, let's keep that. Render queue. Okay, so we can just ignore the rest, right? They've got some defaults. Okay, so how big do we want our buffer to be? So go to and review. Let's just create byte array. So display width. So we want to draw at least one line. Okay, let's just do display width over 2 times our height, display height over 2. Sorry for that. Come on. Okay. And we gotta multiply that by 2. Okay, and so yeah, we can just get rid of this here. And so got our display width, our display height. We pass in our buffer, right? And the important thing to note is that our buffer is not the same size as our display, right? And we pass in the format, and yeah, we create our display. So let's just run this. So I need to attach. Let's hit this. No, I'm not gonna do that. I'm just gonna run this and be. Oh, so we need to call this. Screens. Okay, so I guess we ran and there were no errors or anything. So maybe we could have printed hello world or something. Let's just do that. So yeah, cool. All right, so we know it's running. So what is the next move? Oh boy, I'm so tired. So what are we going to do next? We've got our screen, blah blah blah. Okay, so now let's say we wanted to render. I just add some comments so it's clearer. So we're gonna say we initialize and we share and share got it. And then we can just say we can share driver, then okay, hopefully it's easier to follow along. Cool. So now we need so how are we going to use this if we wanted to say fill the entire screen, but we only have this a half of the width and half of the height, right? So what we're just going to do is look at the size of the render and move our display buffer to the area where we can draw, right? And by doing that, we can we can completely draw the entire screen. Sorry, I just blanked out for a second. I forget that I'm also live, right? So let's give that a go, right? So if we wanted to say maybe let's start with fill rect. I guess that's simple enough. Right now I've got this add draw call, right? Which is neither here nor there, but let's just get rid of that. Also, I wonder if I can get rid of this MicroPython native shit. Sure. Right, so we can just go ahead and copy that, right? Let's copy our add draw call, and then I'll explain what that is doing. Right. It'll make sense eventually, right? So how this works, I just want to copy that, and let's come back here, and right. Okie dokie. So let's fix some errors. Just got time. Yeah, just do U time then. Draw queue. Yeah, we didn't. I don't think we brought over our draw queue, right? I think it's just a DQ. Draw queue, yes, a DQ. And we can come here. Oops. And set that up. but we won't use this right now. I'll just I think it's from collections, right? Or U collections. Okay, U collections. Okay, so what do we have here? Shut up. Cool, 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 cool. So, say one more thing. Okay, you know what? Let's start from the top. Say we wanted to. So we've got our screen. Our screen is, we have the width and the height of our screen, right? And we wanted to screen the fill, right? And we wanted to fit it to, I don't know if I have the colors here. Oh my God. Let's just do white. Let's just do, yeah, black. Yeah, so. So, right? So we call fill, and what fill does calls add draw call, right? And so you realize we're not immediately drawing the executing the call, but rather we are so anyways, in this case, we are going to immediately execute it. So let's just go down this path, right? But we don't have to immediately execute the call. We could delay the call to later, and so it won't be it'll be a retained. No, it's not really retained, but maybe in between the deferred immediate mode and retained mode, right? So let me just copy these, and so these are just the calls that these are just to help us know what we have to draw, right? So once we get the gotta add that here. Say from Python const Coolio. So we call our draw call, right? And let's take a look. If not argin is minus, maybe I should. So we're checking if our width and our height is 0 or invalid. We do not execute the call, or do not append to it. Maybe we could or we could even check it at the point where we add. But that will mean I have to add this to all the functions, right? Yeah. I should probably just copy and paste this because I've probably already thought about that. Yeah. If I check if width and height is 0, then that means I'll have to check for in each function, right? And we can just check it in one place. I guess this is just to see if I don't want to have to repeat myself. So we check if our width and our height from our list is valid, and then if it's not, we return. If it is, we make sure it is, or we clamp the maximum values of the render to our display width and our display height, right? So if you say you want to draw here and you want to draw something that's 300 pixels long, right? There's no point in honoring that request. The only part we can draw up to is here, right, which might be just 20 pixels, right? So we just want to clamp our values, right, to within the borders of our display. And so we do that here. Skip render, I don't know what that is for, but we'll ignore that for now. And right, so here we are appending to our draw queue, right? And we should set an option here to see maybe immediate, well, let's see, use queue false. Okay. And skew. Great. So when we get here, if we don't want to use a queue, if queue, then else, we just want to go ahead and render our okay, so now let's see how render call is implemented. Okay, so now to render our call, right? Usually it could go into so we have just a bunch of function calls, right, that describe what we want to do, right? And excuse me. Okay. Back now. Okay. Just want to keep it as it is. I don't know why I keep having to deal with these. Okay, so let's just do blah 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 blah. What is a render call? Sorry. Oh yeah. And what does this do? Right? Okay, so once we put it into our draw queue, it comes into our fragment renderer, right? And we check if there's anything in our draw queue. And then if it is, what is it called? Okay, pop left. And then we call render, which is render call is sync. Blah, blah, blah. Okay, so let's just go with the render call for now. Cool. I'll walk through this, but these two are pretty much the same, except with yeah, I will explain as we go along. So let's just go ahead and just copy that, and all we have to do is paste that here. Whoa. Okay. So let's see what kind of errors you got here. What kind of shitty paste is that? Okay. Oh my god, I am exhausted. Okay, I'm gonna take a little break, be back, and we will proceed with the rest of the stream. How can I do that? Let's see. Just gonna create a new. Let's just say ERP. Excellent. So, thanks for tuning in. I'll be right back. Okay, and we're back. So thank you for sticking by. Let's get right back. Okay, so where were we? We were at yeah, render call. Right, let's just get rid of all this extra space. And for now, let's just comment this out. So first thing we do is we create our buffer, right, in case with our width and our height. Cool. And so let's find that function. And so what this does is check if the requested width is bigger than the buffer length, right? And we see how wide we can make it, right? I think it's faster to draw horizontal pixels than vertical pixels, right? In fact, we'll test that later on. So we calculate what we can draw, like how many lines we can draw, and we return you that buffer, right? We create a frame buffer object. We return you the buffer that will be used for the display, and we pass in our width and our height, right? Okay. So what do we do with that? So we check if we got the exact amount of the width we're requesting, right? If it's the width we're requesting, then we know we can just go ahead and complete the entire call. That means we have enough space to complete it in one pass, right? And so this should be driver. And we start our render, right? And this we call start render with the positions that we want to draw, and it returns us a function to draw and a function to call once we are done, right? And so we how do we set this use chunk? Okay, right. So if we we have enough space, we do not set our use chunk, and so what it does is it starts at the beginning, right? And then of our screen, figures out where we are, and then draws a horizontal line. Moves the buffer there, right? So we clear our buffer, right? We start at our X and our Y, right? We do call, right? So let's just do our call. So what do call does is actually implement it is a wrapper around the actual frame buffer calls, right? Right. Okay, and so here we actually fill in our color, and here right now we're just gonna go use our just the color, whatever argument you pass in, right? And so this just fills in our buffer. I will, you know what, I'm just gonna replace this. I want to get rid of we want to just and if I'm getting, I apologize for the language. Okay, so what I want to do is replace this with this. Well, this sucks. Okay, let's see if we can do anything better. Let's get rid of that. Let's get rid of that. Let's get rid of that. Cool. And we will skip this for now. And also we'll skip these and just work on this, right? And then finally we call our driver render start chunks, and then we are done. Okay, so let's go ahead and see if that works. So we've got our buffer and we've got our screen, and we turn it on. Then we can go ahead and fill. It's contemplating, yeah, to just import the color functions or what to do. I'm just gonna copy and paste this. Okay, and maybe we'll add it to our screen. Okie dokie, and then we got this. Where are we? We are on screen. Cool. I should put this somewhere. At the top. There we go. Cool. So we pass in our colors. Let's just do colors index 1. Sure, colors index 0. And then let's do time. Yeah. Okay, let's see if that works first. Excellent. So we managed to fill the screen with only a quarter of the memory. Now let's just time how long that takes, right? And create our screen. Okay. And let's say T0 will take you time, 6 milliseconds. And that takes diff time, that takes milliseconds. T0. And then we just want to print DT. And we want to see for I in and let us just set this to colors, right? And we just want to print. Let's just do something better. Let's say G. Sure. And let's get this. Okay. So we can see with a quarter of the memory, we are still rendering markedly faster than. We can go ahead and run that again. Same thing. We're filling out rectangle and then just timing how long it takes. Right? So all we do is okay. So as you can see with the Python implementation, we are at 140 milliseconds doing the same thing, right? Okay. So now let's see what happens if we say reduce the buffer even more. Let's just do this by 4. And let's give this one more go. And we are still doing fantastic, right? Let's just see how much we can push this. So display width, right? And so, and let's just see how much space that is. So a display is 320 divided by 8 times 240, right? And so we have gone from 320 times 240 times 2, right, to that, right? And we can go lower, right? Let's just do 10. Or for one line, right? That'll be 320 times 2, right? 320 times 2. That is just saying our display width is display height is 1. Okay, so let's say with 640 bytes, right? Let's just hard code that. So we can verify that for ourselves. And there we, just gonna reorder this. Okay, and let's give it this one more go. And it's still faster than Python, right? And that is using only 640 bytes. And so from here on, you can kind of trade memory for performance, right? So let's Okie So I hope you kind of get the point. And so I'm going to just flesh this out, probably offline, and then I'll publish it. I will update the link in the description to the repository so you can try it out for yourself. Let us see what happens if we say we use the entire screen, right? So it's 74. So that is half of the screen. And let's just go ahead and save that. So on average, we've added about a 10 millisecond overhead, but we can go ahead and apply some super simple optimization. For example, just wrapping some of these functions in MicroPython.native will give us easy performance boost. So why don't we go ahead and do that? So we got MicroPython, you know what? Let's just do native. And so let's give it a head and try that. Native. That. Okay. So there'll be one more part where we talk about moving some of these operations. So right now what's happening is our CPU is writing all the data to our SPI's buffer, right? Our SPI's FIFO. And what we'll do in the future is we'll use DMA to move data from our buffer into the SPI so that we can do other things, right? So that is about it. What was the last thing that I did? All right, so we're wrapping this in native. Sure, why not? And let's just see what happens. I just knew that would happen. Let's just do microPython. And now we gotta add these. Okay. That should be that. And yeah, we save an additional 1 or 2 milliseconds. there's probably more optimizations to be had, but let's see. For now, we are looking good. The goal to beat was 140 milliseconds, and I'd say the target to beat, sorry, was 140 milliseconds, and I'd say we achieved that quite handily. So looking for ways where, because this takes I wonder if something to do station 0. Let's see. And so about the same. Yep. We are rock solid at 60 milliseconds a frame. If you notice anywhere I could improve the performance, you could let me know. Yeah, like I said, I will update it with the rest of the render functions, and I will publish a short description and explanation, right? Okay, so thanks for tuning in again, even though I know no one's watching. If you made it all the way, please like, please subscribe, and I will get better and make better videos and more entertaining videos. So thank you, and I will see you next time. Cheers.